This video will demonstrate the capabilities of our real-time spectral deconvolution systems. We mathematically deconvolve spectrometer output and plot concentration of each component in real time. We monitor concentrations. My name is Gary Yannick. I'm with PDR-Separations. Introduction. Objective. Mathematically deconvolve spectrometer data and plot each component's concentration in real time. We can configure with Agilent DADs, fiber optic spectrometers, etc. We can deconvolve even similar spectra in real time. We monitor flow concentrations, peak purities, etc. We monitor mixtures and feedback for automatic control of composition. We demonstrate good limit of detection, limit of quantitation, linearity, etc. Concentration monitor block diagram. Flow cell with liquid flowing through unobstructed. Light source typically connected via a fiber optic cable to a flow cell. Another fiber optic cable taking the resultant light from the flow cell to the spectrometer. And finally, a USB cable into a PC. Processing, display, external events, and usually the entire system are controlled by PDR software running on the PC. A robust flow cell. The flow going through unobstructed. Light source coming in from the lower left in the fiber optic cable, and then in the upper right, the fiber optic cable going to the spectrometer. Here is an isatin indinone deconvolution example. Notice they have similar spectra, but that's not a problem. We still give quality deconvolution. Here is detail about that example. This was taken on an Agilent 1100 with diode array detector recently here in my lab. No column, methanol at 0.15 milliliters per minute. Isatin and indinone vials were mixed at 0.03 milligrams per milliliter in methanol. The next 5 vials were volume mixed at 50-50, 67-33, 33-67, 80-20, 20-80, as shows on the screen. 3 microliter injections, 90 nanograms each. The next slide is this very chromatogram screen recorded and then speeded up 50 times so it doesn't take so long. So you'll notice that the deconvolution on the left is in sync with the raw spectrometer data in the 3D display on the right. So the deconvolution really is happening in real time. And as further evidence that this is truly deconvolution, notice that the red isatin peak has a little shoulder on the rising edge. It's not nearly as Gaussian as the blue indinone peak, and those peak shapes are preserved on each one of the elutions that are coming out in real time that you see in this screen recording. I won't continue to the end. In summary, we mathematically deconvolve spectrometer output and plot concentration of each component separately in real time. We can apply this at any scale, any technique, reaction monitoring, HPLC, SMB, CCC, process, etc. We can configure this with Agilent DADs, fiber optic spectrometers, etc. Makes easier and faster optimization of methods because you see internal profiles continuously. With feedback to flow control, you can maintain mixtures even if the feedstock is varying. You can replace or reduce the need to extract samples. In summary, you have problems, PDR has solutions. Thank you. Again, Gary Yannick, PDR-Separations. Have a good day.